So here are some general shapes of functions that I would like you to memorize. We call them the parent functions. This is the 8 graphs shown below represent the most commonly used functions in algebra. The most commonly used functions in algebra. The first one is the constant function. Notice it is a line. It is a line, but it is a horizontal line. So that's f of x equals c. C represents some constant, a constant like some number, 1, 2, 3, -5, -2, 0, for example. So C represents a number here. Sort of like when you were asked in intermediate algebra to graph y equals 2 or something. All right, in this case, it looks like the number is here, some number between 1 and 2. So for example, this function could be f of x equals 1.3 or something. So that is that function. Memorize that the constant function is a horizontal line. The next one is the identity function. It is f of x equals x. So whatever x is, it will be your y. For example, this point right here is 1, 1. This point right here is 2, 2. That's called the identity function. Now both of these functions here are linear functions. So the broad term will be linear functions, but those are just some unique linear functions. The constant function and the identity function. The next parent function I would like you to memorize the shape of is the absolute value function. What does it look like to you? What does it look like? And you probably want to write those features down so that it'll help you memorize the shapes. So this is like a V shape, right? Isn't it V shaped? So the absolute value is V shaped. Absolute value has those little vertical bars surrounding the x. So that's the absolute value symbol. The next parent function I would like you to memorize the shape of is the square root function. What would you say this looks like in your opinion? So this is the square root of x. And in a few minutes, I'm going to show you how these graphs get their shapes, okay? But for now, I just want you to memorize the shape. So give me a description of this square root function. All right. In the past, some of my students have said rainbow. So I'm going to put that down for you. Rainbow, just in case you said rainbow. All right. Next, we have the quadratic function. The quadratic function, as you can see, is a parabola. Put that word. This shape is called a parabola, but obviously is U-shaped. U-shaped. It's a U-shaped function. All right, that's f of x equals x squared, the quadratic function. It is also actually known as the squaring function. Squaring function. I do not use square function a lot. I use quadratic function mostly. But you may hear it being described as the squaring function. All right, the next function is the cubic function, f of x equals x cubed. How would you describe how it looks? I always describe it as a snake-like function. That's the cubic function, x cubed. The next function is the reciprocal function. How would you describe it? I've heard some students say boomerang. So I say, okay, boomerang. And then the next function is the greatest integer function. And you may say something like, what would you say? Let's see if you said steps or stairs. This function is used mostly, primarily, for computer science. So if you're a computer science major, you actually may see this in your area. All right. So it says fill in the blank. The constant and identity functions are a special type of function called what functions? So as a review, what goes in the blank? You said linear, you are correct. Again, linear function is the broader term, but there are some special type of linear functions called the identity function and the constant function. All right, familiarity with the basic characteristics of these simple graphs will help you analyze the shapes of more complicated graphs. So this is why I want you to memorize these parent functions, because these parent functions have children functions. So it would be best if you knew the origins of those children functions, because or those offspring functions. If you knew the parent functions, it'll be so much easier to understand where those functions got their shapes. All right, let's review how these graphs get their shapes. So we're going to graph right now. Let's graph f of x equals x squared. Now, which function is this one? F of x equals x squared. So if you said the quadratic function, you are correct. Here it goes right here. It's going to look like a U, but we are going to use a t-table to graph this function. Do a t-table. Let's put x on one side. Let's put f of x on one side. This is not a line. So because we know that it is not a line, we know that we need to plot more than 3 points. All right, so let's plot. Let's go with -2, -1, 0, 1, and 2. If we plug in -2 into x squared, we get f of -2 equals -2 squared equals 4. All right. So our point is -2, 4. If we plug in a -1, we get -1 squared, which is +1. So that is -1 comma 1. Plug in a 0, we get 0 squared. Plug in a 1, we get 1 squared is 1. And plug in a 2, we get 2 squared, which is 4 again. So we got points 0, 0, 1, 1, 2, 4. And because we know the shape of this function already, we know that we need to curve this. It's not going to be a rigid line. It's going to be a curve. So -2, 4, let's go to the left 2 units. 1, 2, go up 4. 1, 2, 3, 4. -1, 1, left 1, up 1. 0, 0, 1, 1, and 2, 4. So you can see that it looks like a U-shaped function. So again, we know it's supposed to curve, so make sure you curve. We only are plotting how many points here? We're only plotting 5 points, but obviously there are infinite number of points on this graph. We are only just plotting 5 points. Now that we have graphed it, let me ask you a few questions. Is this an even or odd function based on the information you've learned so far? Several ways you can do it. Since we graphed it, we can see that this function is symmetric with respect to the y-axis. Therefore, it is an even function, right? So we can fold this function across the y-axis evenly. So this is an even function. Here's another question. What is the domain of this function? Domain. So the domain are all of the x values. As you can see, this function is going continuously in this direction on the x-axis. Where is that going? That's -infinity. And then it's going continuously this direction on the x-axis. So it's going from -infinity to +infinity, or you could say all real numbers, or you can put that symbol with the double R. All right, the next one. What is the range? The range are the y values. So the bottommost y value would be in this point here, right? So that would be 0. That is a point on the graph, so it would be a bracket here, comma, to infinity, because this function is continuously going in this direction on the y-axis. So it's from 0 to infinity. Some other questions I could ask you: where is this function decreasing? This function is decreasing. If you trace this function, it's going down here. It's going down from here to here. So that's from negative infinity to 0. It's decreasing from negative infinity to 0. Decreasing. Negative infinity to 0. And we always use parentheses for increasing, decreasing, and constant. Where is it increasing? All right, increasing from 0 to positive infinity. It's increasing from here to here. So on the x-axis, that's 0 to positive infinity. What is the relative minimum? The minimum point is 0, 0, for example. So these are some typical questions I could ask you to review pretty much the things that we've covered in the past. All right, let's move on to the next function, f of x equals x cubed. Which function is this one? What function is this? This is the cubic function, right? Cubic function. So if we draw a t-table, f of x equals x cubed. Again, this is not a line, so -2, -1, 0, 1, 2. We want more points involved here. F of -2 equals -2 cubed, which is -8. F of -1 is -1 cubed, which is -1. F of 0 equals 0 cubed, which is 0. F of 1 equals 1 cubed, which is 1. F of 2 equals 2 cubed, which is 8. Let's plot that. -2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So we went down to -8, -1, -1, 0, 0, 1, 1. Notice we are going up from left to right. So we are increasing from left to right. 1, 2, 1, 2, 3, 4, 5, 6, 7. Somewhere here. And again, know the shape so you'll know that it's supposed to curve a little like a snake here. Do that. Curve it just a little. All right. So this is the cubic function. It's definitely not an even function. All right. This is an odd function here. Odd function. And the way I know it is because you can take half of it from here to here. You can reflect it across that y and then reflect that piece across the x, and you end up with the other piece of the function. So it's symmetric with respect to the origin. Symmetric with respect to the origin. Now, I could ask you other questions. I could ask you, what is the domain of this function? It's from negative infinity to positive infinity because it's continuously going in this direction to the left on the x, and it's inching surely, slowly but surely, it's going to the right, inching its way that way to the right in both directions. So that's negative infinity to positive infinity. Same thing with range on the y, negative infinity to positive infinity. I could ask you, where is it increasing? It's increasing everywhere, negative infinity to positive infinity. So from left to right, if we traced it, it's going up continuously. It never is constant, even though it may look like it's constant somewhere in the middle, but it's actually not. It is actually increasing everywhere. All right, let's move on to f of x equals the square root of x. So what function is this? This one may be obvious. It is the square root function. What is the shape of this? Well, let's find out. It's best to kind of have an idea before you graph. So we have x and f of x equals the square root of x. Now this one is a little different because we know there are some restrictions when we have radicals. Think about domain and when we have restrictions on domain, when we have a radical. So what numbers would you want under this radical? You need to think about those things. For example, it's perfectly fine to have a number like 0 under the radical because f of 0 equals the square root of 0 is 0. It's perfectly fine to have 1 because f of 1 equals the square root of 1 equals 1. But you may want to choose some numbers that you know the square root of, like 4. F of 4 equals the square root of 4, which equals 2. What about 9? F of 9 equals the square root of 9 equals 3. So here are some points that we have. 0, 0, 1, 1, 4, 2, 9, 3. So we discussed the square root symbol. We said it's going to look like a shape of a rainbow. So we're going to start here at 0, 0, 1, 1. So it's doing something like this, all right? And we got to curve it a little bit. We know it's not a line. It's got a curve like a rainbow, all right? So that is the square root function. Recall that when we have square roots and we talk about domains, the instructions were to set what's under the radical greater than or equal to 0. So that's why we only use numbers that were greater than or equal to 0 because we don't want negative numbers under there. That's why there's nothing on this side, right? These are the negative x values, but that's why that function does not go in that direction. All right, now I could ask you for this one. What is the domain of this function? All right, so what do you think the domain is of the square root function? Well, it starts here on the x-axis, so that's 0, 0, 2, and it's going on continually that direction on the x-axis, so that's 0 to infinity. And that is a point on the graph, so we will put a bracket there. All right, range on the y-axis is at 0 too, and it's going continuously up. See how it's going up? It's going continuously up, so that's infinity as well. Where is it increasing? Well, it's increasing from 0 to infinity. Now with increasing, decreasing, the constant, we always use a parenthesis in this textbook and not a bracket. All right, the next function, f of x equals 4. What type of function is this? All right, so recall that I said that if we have a number there, then we know that this is a constant function. And what does it look like? It looks like a horizontal line. So when we do a t-table like so, for f of x, what should we put under here for f of x? Well, it says f of x equals 4, so we will only put 4 because f of x equals 4 only. It doesn't equal anything else but 4. X, you have uh, full autonomy to pick any number you want to pick. So if you wanted to pick -1, 0, 1, that's fine. It doesn't matter for x as long as f of x is equal to 4. All right, so -1, 4, 0, 4. Okay. So let's draw a horizontal line. This is our function here. All right, so what is the domain of this function? domain is negative infinity to positive infinity, so hopefully you got that right. Range is kind of strange. Yep, the range is kind of strange. Notice that the only y value it covers. What is the only y value it covers? F of x equals y, right? The only y value that it covers is 4. And we put that in braces. This is how you write it in the right set builder notation. You put it in braces and you put 4 inside those braces. That's the only number the range covers. There's no other y value that this function covers. This function is constant from negative infinity to positive infinity.